Okay, guys, so now we're going to put all of this slope stuff into real world applications. So don't freak out by this. What we have here is a table. So you just had tables. Hold on, I put my thing away. So let me pull this back out. So you just had tables. We just did tables like this, okay? And all it did is it gave you X and Y values. You had tables, you were able to solve this, okay? So now what happens is we have this XY table, but my XY table's sideways. Doesn't mean anything, it's just sideways. So the value that's on top is going to be our X value, and the value that's on the bottom is going to be our Y value. So we have X and we have Y. So this says the table shows the high temperatures in degrees Fahrenheit, so this high temperature is degrees Fahrenheit, of a city during the first part of June. Find the rate of change in high temperatures between June 1st and June 6th. So a minute ago when we did this work, we just went in and we picked any 2 points. Remember, so we looked at this and I said for the first problem, we're going to look at points 2 and 3. And for the second problem, we're going to look at 3 and 4. And for this one, we're going to look at 1 and 2. Well, here it tells us we have to pick June 1st, which is this one, June 1st, and June 6th, which is this one. Okay? Okay, so I'm going to do the same thing that I did up here. Here is my ordered pair. So my ordered pair is going to be 172. And this is my second order pair, which is going to be 676. Okay, so remember I have X and then Y. So find the rate of change. So rate of change is the same thing as the slope. These two things are always interchangeable. If you see rate of change, if you see slope, that means exactly the same thing. So I'm going to use my slope formula. And I'm going to say y2 minus y1. So 76 minus 72 over 6 minus 1. So when I do the math here, I get 4 over 5. Now, the good thing about this is we're going to use our calculator on this. And when we use our calculator on this, we're just going to divide. We're going to divide 4 divided by 5. And I know I have my calculator here somewhere. Okay, so this is 0.8. Now, it's a story problem. It's a real-world problem. So since it's a real-world problem, I have to have a unit. So if y is on the top, remember it's, oh, I didn't write my formula down. I should have done that. y2 minus y1 over x2 minus x1. So when I get my final answer, it's going to be the unit for y on top, because y is on top down here. Right? So it's going to be 0.8 degrees Fahrenheit per day. Go back to what we did with proportions. We're going to have a unit in the top because I have a numerator and a unit in the bottom because I have a denominator. So this is my final answer. Okay? All right, so this next part of the question says, find the rate of change between June 6th and June 8th. So now this time I'm going to still use this point. This is June 6th. And I'm going to use this point. This is June 8th. Right? So June 6th, June 8th. So I use these 2 points. So my 2 ordered pairs are going to be 6 and 76. 6 and 76. And my second ordered pair is 8 and 84. Okay? So if I know that this is x1 and this is y1, then this is x2 and this is y2. So I would have 84 minus 76 over 8 minus 6. And that gives me, let's see, 8 over 2, which is 4. Now, my units again, my units of y is on the top, y is degree F, and x is going to be day. All right, so this next part of the question says, during which of these time intervals did the temperature rise faster? Well, if you think about this, so in the first time interval, let me go back to this. The first time interval, it was 0.8 degrees F per day. And in the second time interval, it was 4 degrees F per day. Okay, so when did the time interval rise faster? Well, for sure right here, right? 4 is way bigger than 0.8. So the answer to this would be between June 6th and June 8th. That would be the answer to that. Okay, I'm going to pause this and I'm going to let you work through number 2, the same with your table partners. So this is exactly the same thing that we did up here, right? So Josh started a diet and decided to record his weight every other week. So here's the weeks. So week 0, week 2, week 4, week 6. All right, and here's his weight for all of those weeks. So find the rate of change between week 0 and week 2. So the first problem, we're using these two, between week 0 and week 2. The next one says between week 2 and week 4. So week 2 to week 4. And then we want to look at week 4 to week 6, and then finally week 6 to week 8. Okay? So go through this. Remember, we're using the formula y2 minus y1 over x2 minus x1, and you have to have units. Units are super important. Okay? So go ahead and work through this and think about what's happening here. So he starts at 224. He goes down to 219. So the first 2 weeks, his weight goes down. You'll see that in your answer. And then, his weight goes back up. And then it goes up, and then it stays the same. So go ahead and work through this, and then after you've done that, come back and we'll check answers. Okay, guys. So here are the answers that I came up with. So this first one is negative 2.5. So what does this mean? This means that he lost an average of 2.5 pounds per week. This negative tells me that he lost weight. So he lost weight here. We knew he lost weight because we can see it right here, 224 to 219. Okay, so this is my average weight loss per week. Here, we know that it went up, so we know that he gained an average of 1 pound per week. And then he goes back and he lost again. And then on this last one, we end up with 0 pounds per week. Well, we see that up here, right? 215 to 215. So we see that his weight didn't change. He didn't gain weight, he didn't lose weight. But in the math, we see that right here. So we know that this is okay. So the answer to this is 0. And it says explain what this means. It's explaining what it means. It says his weight didn't change. So over that time interval, his weight didn't change. Okay? All right, let's flip it over and look at it from this standpoint. So now we have a couple of graphs. And we have these graphs, and what it says here is the graph shows the number of miles driven after each hour of a road trip. So we see that this is miles and this is hours. Okay, so this says find the rate of change from hour 1 to hour 4. Well, what we're doing here is we're just looking at this from a graph. So from a graph standpoint, we're looking at what these values are. So these are counting by 2s, so this would be 1 and this would be 3. So if I want hour 1, I'm looking at this point right here. So the ordered pair of this point is going to be 160. So the first hour, he drove 60 miles. And then we look at hour 4. So hour 4, he drove 160 miles. And now I have 2 points. I have my x1, y1 point and my x2, y2 point. So now I can find the rate of change. Remember, rate of change is the slope. So I can find the rate of change between hour 1 and hour 4 just by pulling the points off the graph. So I'm using this point and I'm using this point. So my slope would be 160 minus 60 over 4 minus 1. So 100 over 3. Now, if I put this in my calculator, I just happen to know what this one is. It's 33.3 repeating, right? But now I need my units. So remember, y is on the top. This is my y-axis. So it's going to be miles per hour. All right. So for this next one, it's the same thing. We're just using 2 different points. We're using hour 8 and hour 10. So here's hour 8 and here's hour 10. So if I look at my 2 points, my first one is going to be 8. I've got to calculate this right here. So if every one of these, or sorry, every 2, because it's skipping 2, is going to be 100. That means that every one of these lines we add 50. So if I have 360 and I add 50, then I have 410. So that means that this line right here, where this point is going to be 410. Okay? And then this point 10 becomes 460. All right? So here's what happens. I have y2 minus y1, and I know that this is miles. And then I have 10 minus 8, and I know this is hours. So this gives me 50 over 2, which is 25 miles per hour. Okay, again, I'm going to go ahead and pause this video, and I'm going to let you do number 4 by pulling the points off of the graph. Okay, this one was a little bit harder, right? So this was easy up here to see that the difference between these numbers was 100, so I'm going to add 50. Here, to go from 66 to 58, I just subtracted these two, so 66 minus 58. So the difference between these two numbers is 8. So that means that the difference between each number is 4. So I had to take 58 and add 4, and that's where I got 62. Okay? And then I did the same thing for this one. If 74 is the last point I know, I have to add 4 to get this one, and that's where I get 78. Now, what I notice between 2000 and 2004 is I have a positive slope. So that means, and I can look here and I can see that the water depth increases. So because I have a positive slope and the water depth increases, it makes sense that my answer is 4. And it's 4 feet per year. All right? So now I look at 12 and 16, and my water depth decreases. So my slope of my line is negative, so I have to have a negative answer. Okay? Again, you had to calculate those 2 points, and when you do the math, you get negative 4 feet per year. So here it's growing by 4, and here it's decreasing by 4. Okay? So you have to pull in what you know about a positive slope and a negative slope to make sure that your answer makes sense. Okay? All right, so let's do a couple of these where we don't have a graph and we have to kind of figure out what this is saying. So we're going to just do a couple of these, and then you're going to have the opportunity to practice. All right, so this first one, it says, Ava started an account savings with $500. Okay, so she started. That's pretty key right there. After 6 months, her savings in her account was $731. Find the rate of change. Well, I have 2 points. So remember, with all of these, we need 2 points. We need 2 data sets where we can actually pull our rate of change off of. So if she started a savings account with 500, that means my first point means times 0. She has $500. So my value on my X is going to be months. And I know that because of the second part of the question. And my value on my Y is going to be money. All right? So after 6 months, her savings was $731. So after 6 months, it goes to $731. That's how I knew that my X value was months. So now I have 2 points, and I can figure out my slope. So I have 731 minus 500 over 6 minus 0. Okay, so when you plug that in your calculator, let's see, 231 for 6 would be $38.50. So money is my unit on the top per month. Okay. All right, let's do one more. It says an airplane is flying at an altitude of 36,000 feet when it begins descent. So descent means that the airplane is going down. So if the airplane's up here, right, and it's descending, we know that we have to have a negative slope. So we have all these words that begin with descend. So descent means go down, decelerate. Think about anything that's going to go down. So if a candle is burning, it goes down. If you are losing weight, it goes down. So all of these mean that we have to have a negative slope. So an airplane is flying, it begins to descend for landing. 12 minutes later, it's at 29,400. Okay, so at time 0, when I have my airplane up here, so at time 0, my airplane is at 36,000 feet. So my x value here is going to be minutes, and my y value here is going to be feet. So it begins its descent 12 minutes in, it's at 29,400. Okay, so now I have my two ordered pairs. So 4,000 minus 36,000, that's my y value, and then I have 12 minus 0. So if you plug that in your calculator, you get negative 550. Now, my y value's on top, it's going to be feet, and my x value's on the bottom, it's going to be minutes. So it's descending, it's going down at a rate of 550 feet per minute. Okay? Let's see, if you have time, go ahead and do 7 and 8, all right? I'll go ahead and work them on here. You can come back up. If you didn't get all the way through this, remember the answer keys posted online. You might want to go back and do 7 and 8 before you do your homework. Okay, so hopefully you had time. Here are the two answers for this one. Number 7 is pretty easy. Number 8 is a little bit harder. So let's talk about this. So with number 8, it says the population was 16,200 in 2010. If you look at how I did my ordered pair, I put my year first and then my population. Okay, so what this is going to give me, remember I have y over x. So this gives me people per year. So what we're always going to have is we have time in the denominator. So think about that. If we have something like, every one of these, actually, if I go back up here, have hours in the denominator, I have years in the denominator, I have months in the denominator, I have minutes in the denominator. So anything that's on a calendar or a clock is time, and time is always in the denominator. And so because of this, even though my order looks like this would be my x value and my y value, I have to put time as my x value. So that's why this is my x and this is my y. Okay? All right, your homework for today are these rate of change story problems. All right, come see me in help session if you're stuck, and we're going to go over this a little bit together on the next class.